During this presentation, we are going to discuss flea treatments and their effects on biodiversity. Brooks 2021 states that flea treatments are commonly used to protect domestic pets, particularly dogs and cats, from flea infestations, which can lead to a variety of health problems. Fleas are not only a nuisance but can also cause serious issues for pets, including severe itching, allergic reactions, skin infections, and even anemia in cases of heavy infestation. According to Sarah 2024, the most commonly used flea treatments are chemical-based, including substances such as imidacloprid, fipronil, and permethrin. While these treatments are effective in controlling flea populations on pets, their widespread use has raised significant concerns regarding their environmental impact, particularly on non-target species. Some flea treatments contain chemicals that may have side effects, such as skin irritation, neurological issues, or gastrointestinal distress. Tropical flea treatments, often referred to as spot-on products, are capsules of liquid that contain insecticides. Flea treatments are essential for managing pests in pets, but Duncalfe-Youngson 2025 highlights that the widespread use of certain chemicals within these flea treatments has raised concern about their impacts on non-target organisms, especially biodiversity. The chemicals used are highly toxic to insects and other invertebrates. Certain vertebrates are also affected in some cases. The intention of these treatments is to target pests, but has been found to negatively impact ecosystems, particularly when toxic chemicals contaminate the environment through pet waste or direct contact. Environmental contamination, for example soil and water, can occur through pet excrement or runoff. This is being investigated by Dunning 2023, who states chemicals used within flea treatments have been detected in water systems and are impacting wildlife and ecosystems. The highlighted chemicals have been discussed to cause toxicity to non-target species. Flea treatments harm beneficial insects such as aquatic invertebrates and soil organisms. Additionally, neonicotinoids used in flea treatments can harm honeybees and other pollinators. Declining pollinators and other species is a significant concern. These disruptions cause concern for ecosystem services such as soil health and water filtration and food production. Chemicals from flea treatments can accumulate in the bodies of animals, leading to potential poisoning in predators. This bioaccumulation could disrupt entire food chains. Antimicrobial resistance is a highlighted concern through the overuse of treatments due to pests being able to evolve resistance to chemicals. This poses risk to both the health of the pets and the effectiveness of veterinarian treatments. Pesticides in flea treatments impact soil health. This disruption has been discussed to affect soil organisms such as earthworms and have cascading effects on biodiversity and plant growth. Ethical concerns for non-domestic animals. The use of chemicals found in flea treatments raises ethical questions about the unintended harm caused to wild animals and ecosystems, with the debate of should the welfare of domestic pets be prioritized over the well-being of non-target species? Here, GEM 2024 presents how the insecticides in treatments such as spot-on, tablets and flea collars contaminate the environment. This figure shows several ways in which chemicals can spread, such as washing off during the rain, and other organisms that are affected. Primary welfare issue associated with chemical flea treatments is their harmful effect on biodiversity, particularly on insect populations such as pollinators and aquatic invertebrates. Neonicotinoids, commonly used in flea treatments, has been linked to the decline of the honeybee population, which play a vital role in pollination. Imidacloprid and fipronil, for example, are powerful insectinoids. One monthly flea treatment for a large dog contains enough imidacloprid to kill 25 million bees. These chemicals have been reported to disrupt the neurological functioning of bees. The loss of such pollinators can have cascading effects on ecosystems and food productions, as they are crucial for many crops and wild plants, which has been discussed by McMamner 2024. Nestling mortality has been associated with contamination from chemicals found in flea treatments. King 2025 reports that songbirds are inadvertently killing their young by making nests out of contaminated pet fur. Tassindin Montang et al. 2025 conducted specific research and found that 100% of blue tit and great tit nests are contaminated with pesticides from pet flea treatments. This study, funded by the charity Songbird Survival, also found that nestling mortality is associated with higher levels of the pesticides. In addition, these chemicals have reportedly caused harm to aquatic ecosystems, affecting species such as water fleas, which are a critical part of freshwater food chains. Pollution of water bodies. The chemicals from flea treatments can enter aquatic ecosystems through runoff or waste. Studies have shown that imidacloprid, for example, can have toxic effects on aquatic invertebrates, which are vital components of food webs and ecosystems functioning. Additional implications caused by pesticides are environmental, specifically impacting soil and earthworms. This non-targeted toxicity causes effects on behavior, reproduction, and overall health of earthworms, implicating their environmental benefits. Stronger evidence in relation to mortality in earthworms is linked with fipronil. However, imidacloprid has also shown toxic effects leading to negative long-term population challenges. As discussed, pesticides can accumulate in the soil and enter waterways through runoff, affecting aquatic life and potentially entering the food chain. This additionally reduces soil enzyme activity. Some studies have shown that pesticides can alter soil enzyme activities, which are crucial for nutrient cycling and soil health. While flea treatments provide direct benefits to animal welfare by controlling flea infestations, the environmental impact poses a significant challenge. There is a need for more research into safer, more environmentally friendly alternatives to traditional flea treatments, as well as policies that regulate chemical usage and promote sustainable alternatives. In addition to biodiversity implications, as previously highlighted, flea treatments are used to promote positive health and welfare for pets. However, it is recommended by vets to use these treatments on a monthly basis as a preventative, not just when infested. Rust 2016 reports that excess use of chemicals can contribute to insecticide resistance. This is supported more recently by Rust 2024, who further expands, stating there has been no recent studies in relation to the chemicals used in flea treatments and resistance effects, implying research to be desirable in the efficiency of regular preventative treatments. Additionally, Horton 2025 states there is no requirement to treat pets for fleas unless they are infected, claiming that promoting preventative monthly treatments is only profiteering. He compares this to children, highlighting that they are only treated for nits when they are present. These reports suggest preventative monthly treatments not to be beneficial. Controversially, Stilwell 2018 states monthly treatments to be beneficial for pets, highlighting the benefits such as preventing infestation, protection against flea-borne disease, and reducing the risk of anemia. This is further supported by ACRA 2023, who expands on these benefits. These include the prevention of flea eggs in the environment, ultimately breaking the flea life cycle, the improvement of comfort in pets, and the low maintenance convenience for pet owners. Flea treatments and their effects on biodiversity have shown controversial benefits and implications. Reviewing ethical considerations could highlight the understanding of these debated elements. From a utilitarian perspective, the ethical value of flea treatments hinges on a cost-benefit analysis. Flea treatments improve the welfare of pets by alleviating suffering due to infestation. However, as Baumann 2019 details, the environmental harm caused by these treatments, such as the impact on biodiversity, may outweigh the benefits, especially if long-term ecological damage occurs. The utilitarian argument would call for a balance between the well-being of individual animals and the broader ecological consequences. In a utilitarian framework, the key consideration would be whether the overall positive impact on pet welfare outweighs the potential negative impact on biodiversity and ecosystems, highlighted by Marcil and Kahn in 2019. If the environmental harm outweighs the individual benefit for pets, then utilitarian ethics would advocate for minimizing or even eliminating the use of harmful flea treatments, encouraging the adoption of more sustainable practices and alternative solutions that maximize overall happiness and well-being for all affected parties, including non-human animals and the environment. From an animal rights perspective, the ethical use of flea treatments is justified if they do not infringe on the rights of the animals. As Werbel 2009 highlights, the rights of domestic animals to live without suffering from flea infestations could justify the use of flea treatments. However, the broader question arises regarding the rights of non-domestic animals affected by these chemicals, which may be considered in violation of their right to live without harm. Over-medicating an animal without necessity may be seen as an infringement on its autonomy and well-being, detailed by Suku 2020. Additionally, routine chemical exposure without clear justification could be an ethical violation if it poses health risks to the animal. Schlotz 2024 summarizes that animal rights theory does concern the impact on biodiversity, recognizing all sentimental beings, not just animals, deserve protection. Ultimately, the ethical considerations surrounding flea treatments require a nuanced approach that weighs the welfare of individual animals against the broader ecological consequences, urging the need for sustainable alternatives that prioritize both animal rights and biodiversity protection. To evaluate flea treatment policies and their controversial impact on biodiversity and animal welfare, it's essential to examine the regulations governing chemical flea control products, which focus on public health, animal welfare, and growing environmental concerns. Policies regarding the use of these chemicals have evolved over time, which is demonstrated within this flow diagram. For instance, fipronil and imidacloprid are regulated by agencies such as the EPA, EMA, and APVMA. These agencies ensure the safety and environmental impact of flea products. This is maintained by regulatory approval where products undergo safety testing for pets and humans, including effects on non-target species, which Jeremy 2024 indicates is vital in minimizing harm to pets. Labeling and usage guidelines with clear instructions minimize overdosing risk and environmental contamination. Agencies monitor products after release to address any adverse effects through post-market surveillance. This has contributed to the ban of fipronil and imidacloprid in agricultural settings in many regions due to their environmental impact. However, their use in pet treatments remains widespread. This regulatory gap highlights the need for more comprehensive policies that address all sources of environmental contamination. Environmental policies currently include risk assessments, bans on harmful chemicals, and promotion of sustainable alternatives. Animal welfare policies emphasize product safety transparency and animal testing regulations to minimize harms to pets. Despite progress, challenges remain, with biodiversity loss continuing and policies not fully addressing the cumulative effects of chemical use. A greater focus on eco-friendly alternatives is necessary to protect both the environment and animal welfare. Practices in animal welfare increasingly emphasize finding a balance between the effectiveness of flea treatments and their ecological impact. GEM 2024 indicates the development of policies to regulate these treatments has led to a shift towards products that are both effective and less harmful to the environment. For instance, newer formulations like the use of nematodes to control flea populations prioritize biological controls or low toxicity substances over traditional chemical methods, reducing ecological harm and helping mitigate some of the negative effects on biodiversity. However, the effectiveness of these alternatives can sometimes be less predictable than chemical treatments, meaning pets may still face health risks from flea infestations. This creates an ongoing challenge for policymakers and product developers to strike the right balance between efficacy and the environmental safety. Moreover, enforcement of policies remains difficult, especially in regions with limited regulatory oversight, where ineffective or harmful products may still be sold, leading to potential risks for both animal health and the environment. Increased monitoring by agencies such as the EPA and the European Chemicals Agency has helped limit harmful substances, but the continued sale of unapproved products is a concern. In 2025, TASIN explored the topic of public awareness, highlighting its rise, with efforts focusing on educating pet owners about the environmental impact of flea treatments, promoting responsible use, and ensuring proper disposal to prevent further environmental contamination. The use of flea treatments, while beneficial for pet welfare, has significant ecological implications, which Perkins and Gulson 2023 have verified cannot be ignored. The widespread application of chemical-based flea treatments has raised serious concerns regarding biodiversity loss, particularly in non-target species such as pollinators, aquatic invertebrates, and soil organisms. Ethical considerations, including the potential harm to both domestic and wild animals, emphasize the need for a balanced approach to animal welfare and environmental protection. As policies continue to evolve, there is a growing call for safer, more sustainable alternatives to reduce the ecological footprint of flea treatments. Enhanced regulation, increased public awareness, and the development of more environmental friendly products are crucial steps ensuring that both pets and planet can thrive without compromising one another. The relationship between laws and ethical views are significant. Research by Fush 2024 indicates that laws can influence the public's opinion and ethical perspectives. When regulations promote environmental friendly practices, they can lead to increased public awareness and a shift in societal values towards sustainability. For example, the introduction of laws requiring the use of low toxicity flea treatments could encourage people to view these options as the ethical choice, aligning their behaviour with the new legal standards. Ultimately, the interplay between law and ethics underscores the vital role of measured policy making in promoting a more sustainable future.